So obviously, here to talk about CHP, combined heat and power. There are a couple projects, recent or under construction in the state that you'll be hearing from. CHP is, combined heat and power has been a part of our industry for decades, if not, well, probably a century. However, it's really getting a second look for a few reasons. One is there's perceived electricity cost benefits. I'm not entirely sure those remain true, but that's certainly an issue. It's a much more efficient use of energy. When we take wood and make electricity, you capture somewhere around 30% of the energy embodied there. Any heat use bumps that up and can do so significantly. We also have mill residue challenges, discussed a little bit this morning. The sawmill residue situation we have will be turning into a crisis in the spring. Probably not for everyone, but for some of you. And it'll be a difficult crisis that we can see coming and frankly can't see how to fix. So we're going to be hearing from some leaders and some real doers in the combined heat and power space. They're going to be talking about their projects, but also hopefully sharing information you can learn not only about what their project's doing, but how CHP can and can't work in different situations. I'm going to go ahead and introduce our first speaker, and we're just going to go ahead in the order that they were listed. So it's my pleasure to, and we'll be hearing from Alden, then Bob Linkletter, Chuck Qualey with Sappi, and finally Ben with DOE. Many of you, probably all of you, know Alden Robbins. He is vice president and really, you know, in the current generation of leaders at Robbins Lumber, a leading white pine mill. Importantly, he's also a partner in Georges River Energy, which is why he's here today. It's a sub 10 megawatt, and that's an important number, which will be discussed a little bit. Sub 10 megawatt combined heat and power plant under construction at their site right now, and they'll be utilizing some of the heat and selling the electricity. So Alden?
So with our residue situation and challenge, we decided to look at these different avenues and places to go, and luckily we were able to get in touch with Robert Linkletter, who was already well down the path of getting his plant up and going. And so we were able to, you know, bird dog off him, and he was very helpful in making our decision to put in a CHP plant. We already had the infrastructure in place. We had dump stations, we had warehouses, we had yard space, we had steam engineers on staff. So it was a logical step for us to take that path. Wanting to know about energy use, we currently, you know, as a sawmill, you buy a lot of power. About 9.8 million kilowatts last year, and growing every year, it seems like, as we add new buildings and processes. But as you know, we're starting on this new project with an 8.5 megawatt system. CHP project and experience, just what we had on site, and I wasn't involved with that project, as I said before. Very little CHP project experience. I'm not an engineer. I'm just in sales, and I say that every day in our meetings with our engineers and drawings. But you know, we realized we had a problem, and we jumped on it. You know, the program that allowed us really to build a plant of this size was the 2009 CB Rep program. It's the same program that Bob looked into. And that was a legislative program, for those of you who are not familiar, that was meant to geographically disperse power generation in the state of Maine. So diverse it geographically and also by the sources of that power. So they were going after renewable. It had to be under 10 megawatts. The power had to be under 10 cents a kilowatt. So we found out about that program after visiting with Bob. And actually, while we were on the tour, I found out that the program had reopened for a brief window of time. And we had about a week to put in our RFP with the PUC. and you had to have full details on what you were doing for a project, the size of your project, what you wanted to sell your power for, how big the project was going to be. Luckily, just with a strong network of friends and associations in the industry, we were able to put together a strong proposal, and we're successful in getting that proposal to enter into a long-term power agreement with Central Maine Power. Thermal energy is very important to our operations. You know, not only do we use the steam for building heat in the winter, but also for our dry kilns. I mean, white pine is notoriously difficult to dry, and we need constant steam for the heat for those kilns that, you know, obviously as we intend to grow, we intend to use more and more. What have I learned that I didn't know in the beginning? Just about everything. I learned it takes there's a lot to building a power plant, a whole lot. You know, it sounded so easy when we were standing around the table talking about what we're going to do. Let's build a power plant, sure. I mean, we do a lot of things at the mill as far as, you know, put in new carriage tracks or, you know, put in pieces of equipment, redo the outfeed. A power plant's a whole different scale, and it takes a lot of expertise. And so, you know, going right into the last point, which is what advice you have for another company considering CHP, you know, having a good team around you is very important. Luckily, we're able to utilize the wisdom of the past with my uncle and my father, you know, still being on our board and, you know, helping to guide us. Using associates and friends in the industry like Bob, consultants like Eric Kingsley. You know, we're using Mid-South Engineering out of, well, they were formerly out of Millinocket, but now they have a new office in Orono. You know, it's quite a task to consider. There's a lot of people at Mid-South that have a lot of experience with power plants, so using an engineering firm to help you from the beginning, to help you design the plant, give you input, you know, not only in where it should go, but how big, what are you going to do with the inputs, the outputs. I mean, there's a lot of things to consider. As far as assistance, you know, not only engineering firm, as far as assistance that we received on the outside, we did apply for a TIF with the town. That gives benefit to both the project and the community to help reduce the tax burden on the town, the municipal sharing, as well as for the project, because you can have TIFs with credit enhancements. So I'd encourage you to look into those programs. There are the pine tree zones, which we are constructing our plant in a pine tree zone, and I know that's up for debate, and that may not be around much longer. NMTCs is not a route we went, the New Market Tax Credit Program. However, other projects have gone down that route, and there is a potential source of funding for these projects. The investment tax credit or the production tax credit, we are going after the investment tax credit. You have a choice of going after either or. That requires a significant amount of due diligence on your side as far as documenting what you've done, continual progress. They're sticklers as far as making sure that you've met all the standards for that. But that is 30% of total project cost. That's a significant chunk when you start talking about projects that go up in the tens of millions. The CB-REP program obviously helped us go along. Now that program did sunset. However, you know, there is legislation that has been tabled until next year, which sort of mirrors that program. So that is a potential opportunity coming up. There is the USDA Rural Energy for America program that will offer low-interest loans or backing loans, and also grants. So that is a program that we've looked into. We're still waiting to hear on that one. FAME is out there to give financial assistance, and a whole variety of other grants out there. I mean, when you start doing grant researches, I mean, there are people in this room that's what they do for a living, is help people get grants, but there are so many out there, it's hard to fathom. So just knowing what grants you're, you know, eligible for and that you can go for, that's a good road as well. Efficiency of Maine. Our project was a little larger in scale as far as what we did for assistance from them, but could potentially on a smaller scale. They're especially interested in the back pressure turbine styles or some of the smaller turbine installations. And then, of course, just using our educational institutions, UMaine, Maine Maritime Academy. Maine Maritime Academy is really good on the steam engineer side. UMaine, there are students out there always looking for internships as well, so just helping with the staffing. Some of the issues we ran into, cost of project is significant. So financing that project, and as I mentioned, some of the resources out there, that's going to be the number one hurdle is, can we pay for it, and how do we pay for it? Interconnection is another one that can blindside a project. Where is your project located? How are you going to put that power out onto the grid? Are you on transmissions lines? Are you on distribution lines? And believe me, I didn't know the difference. Now I do, and it's significant. Dealing with your local utility, whether that's a mayor or CMP or whoever, it's not easy to get an interconnection agreement. We spent millions of dollars that we didn't think we were going to have to on our particular issue, and everyone has their own particular issue. And I urge you that if you're interested in going down this path, you find out quickly what your issues are going to be. And it's hard to know that from the beginning. We found out that we are on the end of a very long distribution line, and that distribution line did not have the capacity to handle the amount of power that we were awarded to be able to sell back onto the grid. So therefore, we had to rebuild that distribution line. And that's your responsibility to do that. And then there are whole other issues as far as operating and maintenance costs on those lines. And it's a whole other arena that just being people that produce sawdust for generations, we just did not have that skill set. But we had to learn it on the fly. The other part of that CB Rep program is it does require that you are up and producing power to the grid by the end of 2018. So we are up against a hard deadline, and getting these issues taken care of was very important. On that issue, we were very fortunate to have the services of Eaton Peabody on our side, and they were helpful in moving through those issues for us. I'm happy to say those are behind us, and I am also here to apologize for the traffic on Route 3 for anyone who had to deal with that this summer going from Augusta to Belfast, because yeah, that had partly to do with our project. The community, having community backing, very important, not only for TIFs, but just for community support behind you. To have the need and the understanding for what the company is going through, and to have that community backing is very important for public perception, PR. Permitting, obviously it's a power plant, so there's big issues with air, big issues with emissions, site location. We used different environmental companies to help us through that. Luckily, in this current administration, the DEP is more helpful. They're more helpful than they were in the past. They are here to help you get this project going rather than throw up roadblocks and expect you to figure out how to get over those hurdles. Water can be a huge issue. These plants need water for cooling, feed water. For us, we didn't think it was going to be a big issue because we were supposedly on one of the largest aquifers in the state of Maine that just happened to be dry. So we ended up having to dig a large number of wells. We're in close proximity to a protected river. So that posed some issues to us. We had to make sure that our wells weren't drawing from the river. In fact, they were coming from different water sources. We had to prove that scientifically. Fuel, obviously, as well, to heat the water up. What about fuel contracts? What are you going to do long term? We, fortunate and unfortunate enough, have enough capacity at the mill to supply about half our fuel going into our new project. So our current facilities aren't really enough to handle what we're producing for fuel. So luckily, with our new project, we're going to be producing about 8 times as much steam as we were before. So we're going to be able to buy in fuel and hopefully help out our local logging community. And then waste. You will have blowdown water, you will have some wastewater to deal with, and that'll get wrapped up in your permitting, but how are you going to deal with that? Are you in a municipal supply for your water, or you have to, where's your wastewater going to go? What are you going to do with it? These are just a few of the issues that I could think of on the top of my head, but the biggest thing is have a good team around you, and then make that team better as you go along. So we've met a lot of people and worked with a lot of people during this whole process, and we were very fortunate to have some good help along the way.
Thank you for hosting this meeting today. My name is Robert Linkletter. Along with my brothers Richard and Bruce, we are owners of Athens Energy, Maine Woods Pellet Company, Linkletter and Sons, and Linkletter Timberland. My family's been working in the woods for 53 years. Our company structure by design goes from stump to customer. With the recent completion of Athens Energy, the puzzle is now complete. I'd like to explain that. We own 45,000 acres of land, and we have our own forest crews, and we have trucking, and we sort and high grade the wood. We use every bit of the wood. The biomass goes to the biomass plant, but before it can be put in the biomass plant, it is screened, and we'll screen out any good chips and make pellets out of them. The pulpwood will go to the pellet plant, and the logs will go to the sawmills, which we then in turn repurchase the sawdust and the chips from the sawmills to make either pellets or biomass. We also repurchase bark from the sawmills, so we're pretty integrated with most of the companies in the state of Maine. There is no waste, and we're looking into something else to eliminate waste. We're trying to get the highest and best use of our ash. We're currently getting rid of it all now on either farmers' fields or other situations, but we're looking into some other things we can do with our byproducts like biochar or activated charcoal. So there's all kinds of innovation trying to go on in the woods. The idea for Athens Energy was conceived 4 years ago when we had very low temperatures and very high electrical costs. Maine Woods Pellet could not sustain the cost of electricity that winter. So Athens Energy was built on the site that the pellet mill company has, so we were able to utilize multitude of equipment between both companies. I spent plenty of time traveling to Sweden, British Columbia to observe operations of existing power plants made it up to either sawmills or pellet mills, and they're very impressive. CHP is prevalent in other countries where they have been utilizing biomass in their electrical portfolio for many years. We found each situation that we looked at to be different and built to the best serve their host and user companies. Some companies were making steam, some companies went to the route that I did with organic Rankine cycle, and we're making hot air and we were drying that way. When you run a pellet mill, drying is one of the most expensive costs there is. We have to reduce, it takes 2 tons of wood to make 1 ton of pellets. 50% of all of your wood goes up the stack as moisture. We evaporate a 55-gallon barrel of water every minute. Athens Energy is an 8.5 megawatt CHP that delivers not only power, but 9 million BTUs of hot water and 36 million BTUs of hot air to Maine Woods Pellet, which is used in drying of the pellet stock. It's pre-drying the stock. The new CHP provided stability for the pellet company by mitigating the cost of drying frozen wood in the winter months and allow us to run at full speed during months when pellets are in most demand. It also allows us to expand production in the future, which we hope will increase jobs. Athens Energy is an organic Rankine cycle, which is different than most CHP. The ORC boiler and the turbine medium is not water, it is oil. The oil is completely circulated and filtered and reused over and over again. And we go down once a year and we may add to it. We'll check the stability of the oil. The only thing we have to watch out is that we don't burn the oil. Then it'll be ruined and has to be replaced. But the computer takes care of that for us. Since operations began about a year ago, we've seen boiler efficiencies by itself in the 30%. And when we calculate the use of the waste heat that we are able to get out of it, we're over 62% efficient, which is pretty amazing for CHP. Athens Energy has been a real boost for the loggers, truckers, landowners, parts suppliers, and many other local businesses within 100 miles of Athens. Currently, Athens Energy purchased waste bark and chips from about 21 sawmills. The CHP model, if spread across Maine, could truly be in the shot in the arm for the economic growth and stability of Maine's forest industry. Also, if situated correctly around Maine, could truly benefit rural Maine and could help boost and stabilize the grid. We have a great resource in Maine, our woods. It is imperative to utilize every bit of it. We must have a market for the biomass generated from the logging operation. This keeps the wood floor cleaner, not only for faster regeneration, but also reduce fire hazard. The idea of CHP is based on a stable long-term power purchase agreement with utilities. This, along with stable RECs from states recognizing the value of base-loaded renewable power, is crucial. The two programs we were able to take advantage of in building Athens Energy were the new market tax credits and investment tax credits. These programs were essential to get the power plant built. During this huge undertaking, we were bound to encounter some pitfalls. From the power purchase agreement to the interconnection agreement, the electrical connection, to the first power to the grid, the learning curve was daunting. From the financing, the transportation, and construction during the winter months in rural Athens, at times these steps seemed never-ending. With the prize in sight, though, at the end, we have persevered. So are CHPs an efficient approach to reducing energy costs? I believe that they not only reduce energy costs, but they could also stabilize those costs for years to come. Additionally, they will promote many internal efficiencies between the host and user companies. They also promote efficiencies in companies such as sawmills who don't have to landfill their waste byproducts. But we need a carrot on a stick to get people to invest millions of dollars on CHPs and now show some savings to both host and user companies. We need a thermal rec class, federal or regional, that rewards the base-loaded biomass plants that is either a standalone federal or carved out of existing regional recs that are now available. Both New Hampshire and Massachusetts have adopted thermal recs, and I believe that Maine and the federal government should take a look at these positive aspects that are happening in these two states. Another thing that's happened is that the state of Vermont has mandated that by 2030, 60% of all public and school buildings shall be heated by biomass, either pellet or chip form. Just look at the positives. Maine has the highest biomass boiler conversion potential in the eastern U.S. We have millions of acres of renewable forests, and Maine has the most capable logging industry available. Yes, our power costs are high, but most of our power costs are transportation and distribution charged by our utilities. I have found that these costs are historically higher than the cost of the power itself. It is possible to eliminate the T&D by locating installations such as Robbins Lumber near an existing facility, or possibly enticing new businesses with thermal recs, getting them to relocate and have a symbiotic relationship. Additionally, the advantages to the environment are many. The carbon neutrality, the reduction of CO2, and the decreasing dependency on foreign oil top the list. Imagine the emission savings when you compare the transportation of biomass from a 50-mile radius of a facility to the transportation of oil from the southern part of the United States, or worse yet, Saudi Arabia. Even at the current rates, biomass and pellets are cheaper and cleaner heat source than oil and propane. In closing, I believe my experience with CHP has been positive. The marriage with other businesses will help control energy costs, the disposal of waste byproducts, job creation, energy efficiency, and is a win-win for the state of Maine. Maine businesses today, both existing and in the future. Thank you for allowing me to share my thoughts.
Our next speaker is Chuck Qualey. He's a senior engineer at Sappi's Skowhegan Mill. And obviously paper mills, pulp and paper mills are huge energy users, 24/7. They all have their own power islands. So long history of generation, combined heat and power at a different scale, but critical to the forest products industry and really critical to the success of the mill, which is so important to all of us. So with that, please welcome Chuck.
My talk's a little bit different than the first two. We've had a combined heat and power cycle since 1976 when the mill was first installed. I work at the Somerset Mill, Central Maine, Skowhegan, Maine. Mill was put in as a pulp mill in 1976. In the early 80s, we added the first paper machine, mid-'80s the second one, and around 1990, 89 added the third paper machine. So, as I said, it was started and installed as a CHP right from the start. Really, it's kind of a combination of a CHP and a conventional biomass power plant. So we have the ability to run like a conventional plant where you have just a power boiler, turbine, and a condenser, and you make power just like a standalone plant would do it, on top of extraction from those turbines at a higher pressure steam to run the pulp and paper making equipment. So a little bit about the specifics of Somerset. We make on average about 1,250,000 pounds an hour of steam, 850 pounds pressure, 850 degrees Fahrenheit. Very complicated to run. You need the licensed engineers. You need water treatment personnel. You have all the turbine rebuilds, all the things that were talked about earlier. You know, that's kind of our daily life. The thing about Somerset is that they decided to go big. So not only do we have a black liquor boiler, we have two very large hog fuel boilers, multi-fuel boilers. The recovery boiler, makes up about half of our steam production. So we get in something like, Ryan can correct me, 2 million tons of logs and chips, in which we make paper, pulp from. About half of that mass of that material ends up in the recovery boiler. So we burn that half of that 2 million tons as black liquor in the recovery boiler. We have two hog fuel boilers that have the ability to make large amounts of steam. We can burn about 80 tons, 83 tons an hour in one boiler, wet tons, and about 63 tons in the other boiler. And we have two steam turbines. One's a 60 megawatt double extraction condensing leg. The other's 48 megawatt. So we make 575,000 tons a year of pulp, 850,000 tons a year of coated paper. In terms of our energy, 81% of our fuel comes from biofuels into the plant. The advantage of the multi-fuel boiler for us is we burn our pulp mill sludges in that boiler. We incinerate our high-volume gases, so the mill is nearly odor-free to the outside world. And we can bring in different types of fuel. For example, we burn tire-derived fuel, TDF, which helps lower our cost of energy generation. Obviously, 81% of the fuel forest products are extremely, extremely important to us. In terms of the thermal piece, there's something like 9 trillion BTUs a year that go into making pulp and paper, and that thermal piece from the CHP, and all of that's coming from our CHP part of our plant, is extremely important to us. And we put up lots of money into heat exchangers, preheating that feed water, bringing that up to temperature. One of the questions is, you know, what programs do we take advantage of? One of them is Efficiency Maine. We've done a lot of projects with Efficiency Maine. In general, what they did was they would buy down the payback so that a project that the mill probably wouldn't have done became viable, met our hurdle for return on investment. Here's a couple of pictures of projects that have been done. Heat recovery projects off hoods in the paper mill. And basically, without the Efficiency Maine, these projects probably wouldn't have happened in the time frame that they did. Here's 3 recent projects. Hood recovery, 11 million BTUs per hour, 19 million BTUs per hour, 9 million BTUs per hour. Again, that thermal part of that CHP is extremely important to us, and we spend a lot of time making sure that we're using that wisely. So a couple of the issues we deal with is when you burn that much solid fuel, you've got ash that you have to dispose of. And we've made the choice to burn tire-derived fuel with that fuel. So there's wire in the ash, and so land spreading for us, it hasn't been an option. So we're in the landfill business, which again is costly and not the best place to be, but for us financially that's where we end up. The other issue we have is we've recently added natural gas to these multi-fuel boilers, or the larger multi-fuel boiler, and so our usage of biomass can swing tremendously. It makes it very hard for Ryan and his group to supply the mill. Some years we can be 400,000 tons, wet tons. Other years we can be 900,000 wet tons. So that creates other downstream problems in terms of storage, and the years that you have the huge usage, how do you store that material? Talked a little bit about our thermal usage. We also have a lot of drive turbines. A lot of the turbines aren't just producing electricity, they're also running mechanical equipment. The line shafts on the paper mill, 2 of them are completely done with drive turbines. There are vacuum turbines. There are fans on the boilers, large fans, ID fans they call them. Those are powered by steam. So between the electric, the thermal, and the mechanical, you're talking 13 trillion BTUs a year to run that plant. So our CHP project, I said, is, they want to know a little bit about our experience with the project. Our project's been in place since 1976 with an addition in 1990. One thing I will tell you, I see a lot of the other mills. We have a mill in Westbrook, which many of you must probably know is it had a pulp mill back in the, up until the late 90s. That pulp mill was shut down, but the mill still makes a very viable product, but it just has a much smaller thermal usage. And one of the things they're doing with their low-pressure steam is they actually give it away to a local hospital. So that's, they can generate the power off it, and the hospital gets the benefit of the free energy. We have a mill in Gratkorn, Austria, which is, the Europeans do things so well. Their local community was all on a hot water system for heating. And the Gratkorn mill basically has taken some of their low-pressure energy, and they ran 9 or 10 miles of piping to basically feed the local community in doing what they call district heating. So they found a thermal load for some of this kind of lower grade heat. It allows them to generate more power. So that was a really kind of a neat project. It was just done the last couple of years. So in terms of programs, I talked a little bit about Efficiency Maine. The other program we take advantage of are renewable energy certificates. I'm sure most of you are familiar with that product, but basically utilities have a mandate portfolio that says they have to have a certain amount of power from renewable sources, and we can sell the fact that we made the power on site, not the actual megawatts, but just the fact that we made the power on site from a renewable, in a renewable process that meets their requirements. We can sell those certificates. So that's been a beneficial program for us. We talked about room to expand. Was one of the questions we were asked. We're currently in the process of expanding our production. The #1 paper machine is being rebuilt. It's a $165 million rebuild. It's occurring right now. And that's going to get us into slightly different products. We'll be able to swing back and forth. But, we're really trying to make things that people want to buy. So, we're also expanding our woodroom right now and rebuilding that woodroom. That was like a $30 million project. Some of the things, what have I learned, was one of the questions we were asked. And One of the things that's always amazing to me is the fact that a conventional biomass plant, 75% of that energy goes to the atmosphere. You know, part of it through the stack and part of it through what the cooling tower rejects to the atmosphere. And a CHP plant, you know, when we run as a CHP, we're over 60% efficient. So there's this huge swing in whether that energy gets used efficiently or not. Most of the utility plants you see out there are rejecting huge amounts of energy to the atmosphere that, you know, the Europeans have found some ways to use, and CHP is definitely a way to take advantage of that. Advice for companies considering CHP: well, if you don't have a process like a pellet mill, then you need to find a partner that you can that's willing to take your energy. So it's about shopping around for the right partner for that thermal load. We've looked at some of those loads for the Westbrook mill. Certainly, the folks at Gratkorn in Austria found their load as being the district heating up the community. So with that, I'm all set. Thank you very much.
And now our final speaker doesn't have a project, but he works on dozens, if not more, scores and scores of projects. Ben McDaniel comes to us with the U.S. Department of Energy's Combined Heat and Power Technical Assistance Program. Being from the feds, he just handed me something that says he's with DOE, CHP, TAP.
They love their accents.
Yeah. So Ben's here to talk about some of their no-cost services and how they can help bring best practices and learnings from not only this region and this industry, but CHP projects nationally and internationally to your project.
Thank you. Well, thanks for having me out and for the invites. I think because we work on probably about 100 projects a year, it'd probably be good to talk about some of the lessons learned, some successful projects, and then more just focused on our services. We are here, we're a program, we're one of 7 centers around the country to provide combined heat and power services at no cost. So got a list of questions, so I'll start, I guess, by answering those, and then I'd love to take some questions, and if you guys have projects, I'd love to talk to you about that. So we had what makes a successful system. So combined heat and power, I think it really depends largely on the end user and their goals. Often, I mean, most people want cost reductions. Sometimes it's emission reductions. Sometimes it's resiliency. So resilient power for some people it's very important, and they can take a long payback if they have that very resilient power. So to have any of these goals, so what we see is it starts with really good design and proper sizing. And to have proper sizing and good design, you need to know, actually it was great, you were talking a lot about the thermal load, Chuck, is you really need to know what your thermal requirements are and your electric demand, but really more your thermal requirements. That's really important, because if you don't utilize that, that adversely affects your system efficiency and could make it tough to get state rebates or even the ITC or PTC, which is the investment tax credits that usually want you to be above 60%. So if you're not doing that, you're kind of a standalone power generator and you won't be getting these credits. So it's really important. So as far as lessons learned, again, knowing your thermal load is really, really important. And proper sizing is key. So we've seen systems, unfortunately, again, we go screen systems about 100 a year, and then we troubleshoot some. We saw one last year that was way oversized, and as a result, was only able to operate a couple hundred hours a year. This is a multi-million-dollar investment, just sitting because the thermal load was too low, and it couldn't operate at low fire. This is a reciprocating system, so a little different than what we're talking about. But you don't want that. So you really want to know what your thermal load is. I think a lot of people are very concerned about how much electricity can be produced, and kind of the thermal load's an afterthought, and it's really good for that to be kind of in the initial stage is how much thermal energy can I use on site, at what grade, what do I need? So it's really important, and we are here to really help with that. So again, we're the US DOE's CHP TAPS, which is the Technical Assistance Partnership. one of 7 centers. And we offer 3 key technical services. The first being qualification screening. These are all no cost. So qualification screening is if you have a couple years of bills or a year of bills, we can at a very high level tell you if CHP is a good fit for your facility. And the next one is a feasibility assessment. So on a case-by-case basis, we approve very detailed hourly, we'll look at hourly thermal and electric load data and you can talk to your utility and look for incentives and do a very detailed feasibility assessment. And the last is third-party reviews. So if you have a system that's being built or one you're considering or one that's underway, we're happy to give you kind of a second set of eyes, give you our advice as far as from what we've seen and help out. So we highly encourage you, if you're at all interested in CHP, whether it be just curious if it makes sense for your facility, you want to learn a little more about it, or if you're really serious about a project, feel free to call us, email us, talk to me after this. This is why we are here. So utilize our services and ask questions. Again, we're here. We're based out of Western Mass, and that's the technical arm at a UMass Amherst. And we have our kind of legal arm if you need help in that space down at Pace University in New York. And our territories, again, from New York to Maine. So it doesn't have to be just projects in Maine. It could be all over New England. Okay. And then I guess one question was what funding is there available? It seems like a lot of you guys know about the ITC and the PTC. And then Efficiency Maine, I know, has some rebates, and that would be something to look into. And then I guess there is our technical services. Again, they're no cost. Utilize this. We are here for that. And then I think that's it for Maine. I know other states, Mass and New York, are kind of the leaders. They have really, really great incentives for CHP. Mass has basically it has a capital incentive, which is based on the performance and nameplate production. And then an operating incentive, you get basically 2 cents back for every megawatt hour you generate, or kilowatt hour, sorry. So it's really great. So if you're looking at other states, those exist too. And New York also has kind of an accelerator program, which we've seen some systems like fully funded, half by the state, half by the utilities. But for Maine, I would talk to us, talk to Efficiency Maine, talk to your utility, and those are the incentives. But really, we're happy to come out and just, I guess, make you aware that we existed. I'm not sure if anyone knew this service existed. If we give you a show of hands, did anyone know that there was a CHP program around? Okay, we had a couple. And you probably know the Northwest Taps, right? With Dave Schuing? Yeah, great guy. Well, again, we're here, so utilize our services. I'd be happy to take any questions.
So I heard Chuck speak about the ash that comes out of the boiler, and you have to put it in the landfill because it's got tire-derived fuel in it. But I didn't hear Alden or Bob speak to what you did with the ash, and I assume it's probably not going in a landfill.
No, none of it goes in the landfill. Currently, all of it goes on farmers' fields. It's wood in, wood out, no additives. So it's a great potash, soil enhancer. So.
Alden, same thing?
Yeah, so currently we're not having any ash come out of our new system yet because we just poured some concrete last week. So we've got a time before our ash starts getting produced, but you're going to be producing, typically depending on your system, we have a step grate combustor very similar to what Bob is employing. So you're going to have bottom ash and fly ash, and so there's 2 different components. Some of them are easier to get rid of than others. Luckily, these new systems with the traveling grates are much more efficient than our old Stoker grate systems, so you get much less ash than you used to per ton of biomass going in. It's my understanding you have to have your ash tested, so to make sure that of the components and what's in it, to make sure that it is viable for land spreading, and then land spreading or road construction, using it for aggregate and road construction are all viable opportunities. But we're always going to look at new things going down the pike as well. I mean, just additives to potential soil additives and whatnot.
Yeah, both Robert and Alden own and represent companies that are currently in the wood products business, and it looks like, the upfront cost of building one of these plants is tremendous. I question, are there enough, maybe Eric could So, yes, are there enough other companies in Maine that, in the wood products business, big enough to justify such a cost? Is that?
I would say that there are a few, not everyone, but certainly a few, some of the larger mills. Importantly, and the gentlemen that know their numbers can feel free to disagree with me, but I would say getting a 20-year contract at an attractive rate was a key piece of both of those projects being built, and that opportunity doesn't currently exist. So one of the key building blocks for doing the next projects is having something like that still around, and that the political environment isn't there quite yet. I don't know if you gentlemen would disagree.
I agree. Yeah, I agree. It's one of the main building blocks.
Yeah. So one of the main building blocks is a 20-year power purchase agreement that allows them to sell power at a rate that they know they can finance the very, very high upfront capital costs.
But do these companies have to have a large, use a tremendous amount of wood to justify this?
Nope. Certainly works better with a tremendous amount of wood. For example, Sappi uses a tremendous amount of wood. But yeah. And I'll just point out, you know, I spend a lot of time in the biomass world, but one thing I heard, which I knew but didn't know how publicly it was said, you know, you mentioned a swing of maybe one year you're using 400,000 tons, next year you're using 900,000. Okay, for everyone doing the math at home, that's 500,000 tons. That's basically turning on and off a 40 megawatt standalone power plant, which is nuts to think about in terms of supply chain. So just as we're out there thinking about how important CHP is certainly important at the smaller scale. It sort of creates its own weather and makes its own market at the larger scale.
Question was, what's driving our variability in our biomass usage? And it's basically the energy cost structure. So what's changed dramatically for us is the shale natural gas from the Marcellus Basin has driven gas prices down. We connected a 54-mile natural gas line to the mill 2014. So when the gas price is low, and sometimes it can be very low, it makes sense for us to swap to gas.
Okay, I thought that was.
And that same gas phenomenon, much of the power generated in New England is based on natural gas pricing. So sometimes it's not gas we're swapping to, sometimes we're just buying the power outright.